Hello friends, I hope you all are fine. So today's topic is Newton-Raphson's method, and this is a part of numerical methods. Uh, it is one of the important chapter in engineering mathematics, and the Newton-Raphson method question we can easily find in all kind of competitive exams like in GATE, whether in ESC and even PSU exams. So this is very popular method. So but it is very easy method also. Like if you spare 5 to 10 minutes on this video, it's very easy for you to answer the questions which are related to Newton-Raphson method. Okay, let's start with the Newton-Raphson method. So here, the Newton-Raphson method is used for the solution of non-linear algebraic equations like non-linear algebraic equation and transcendental equation. The transcendental equation means the equation which contains trigonometric expressions, logarithm expression. Like for example, I take x square plus e power x plus 10 equals to 0. Such kind of equation you can consider as a transcendental equation. Like here, the algebraic quantity is there, whether exponential quantity is also present, like that. There is a mixture of all the functions like trigonometric, logarithm and all those in a single equation. We call it as a transcendental equation. Okay, yeah. So numerical methods, they are used to solve the equations, whether it's a algebraic equation or a non-linear or linear. Generally linear, there are some other methods, but we prefer numerical methods for non-linear. And yeah, in this method we are going to solve a non-linear algebraic equation and a transcendental equation by means of Newton-Raphson method. Okay, so here one consideration over here is let x naught be the approximate root of f of x equals to 0. Here f of x is a function of x, and x1 is the exact root, and this h is the correction factor. Like in the x naught which we have assumed or initial value of the root, in that there is some correction factor which is h. So this total quantity is the exact root of the given equation. Yeah, if that one x1 is the root of the given equation, obviously it will satisfy the equality with 0. So when you expand the f of x naught plus h by means of Taylor series, you will get this expression. This is directly I have written from the Taylor series expansion. And when you consider it only till the first order equation, like when you neglect the higher orders, you will get the equation as f of x naught plus h into f dash of x naught. Here f dash of x naught is derivative, like first order derivative. You have to differentiate f of x for the first time and you will get the f dash of x naught. So from this we have calculated the value of h, which is equals to minus f of x divided by f dash of x naught. So the better approximation can be given by x1 equals to x naught plus h. Here we have written the value of h from the above equation. So the final equation will be x1 equals to x naught minus f of x naught divided by f dash of x naught. Here this expression can be written in the general form, and the general form says here it is 1, and in this expression we have 0 0 0. So the right hand side of expression is 1 less than that of the left hand side expression. So here we consider it as a xn plus 1, and here we have xn, xn and xn. This formula is very important, and with the help of this formula itself you are capable of solving all the questions which are related to the Newton-Raphson method. As we consider Newton-Raphson method, it is a second order convergence method. Like the convergence or a conversion or the time taken or a number of iteration we require to reach to the exact value of the solution is relatively less. Like it is a rapid conversion, and that's why just because it is a second order or a quadratic convergence, it converges to the exact root very rapidly. So in other words, you can say it is a rapid conversion, and sometimes they ask in exam like what type of convergence Newton-Raphson follows. So here I have written it's a quadratic convergence. Okay, yeah. So this is all you need for the question solving of a Newton-Raphson method question solving. It's a very easy question kind of, and you can easily attempt and you can easily um, can answer all the questions which are related. Okay. So the first question given is, let me read the question first. Given a greater than 0, we wish to calculate the reciprocal value which is 1 by a by Newton-Raphson method for f of x equals to 0. So the first is what will be the iteration formula. We have to find the iteration formula, and the second part of the question is for a equals to 7 and starting with x naught equals to 0.2, we have to find the first two iterations. Okay, let's consider. Okay, to calculate 1 by a by Newton-Raphson method, first we have to consider this. Let x be 1 by a. Let just consider x to be a 1 by a. We want to find the reciprocal of this value, and here we can write it as an a equals to 1 by x, and just arrange this equation. You can easily write 1 by x minus a equals to 0. So here our f of x we have form which is f of x equals to 1 by x minus a equals to 0. You cannot frame it in this way, which I have shown over here. When you frame it in this way, what the problem arises is, when you differentiate this function f of x, you will get a constant value k that is equals to 1. So when constants are present in the uh, derivative formula like f dash of x, we are not able to find the next iteration in the form of constants. So we avoid this situation. So we don't use this particular situation while considering the equation formation of the Newton-Raphson method. Okay, I hope you understand this point. So the next we have got f of x equals to 1 by x minus a. So here the first derivative of f of x, like f dash of x, is equals to minus 1 by x square. Like from here you can easily convert it. By the Newton-Raphson formula, as we have already discussed, x of n plus 1 equals to x of n minus f of x of n divided by f dash of x of n. This is the Newton-Raphson formula, and when you substitute these values, like from here is your formula, and when you substitute it, this is the value of f of x, and this is the value of f dash of x. And when you solve this equation, which I have solved over here, like x of n plus 1 equals to x of n, and when you separate these two terms, they will get cancelled, and yeah, finally you will get this particular equation. And here is the iterative formula which we can use in case. Okay, so this is very simple equations which we can form, and we can form the iteration formula. By using this iteration formula, we can directly find the answer. Like here the question says first two iterations we have to find. First two iteration means we have to find x1 and x2. These are the first two iteration values. Okay, for a equals to 7, x0 is given as 0.2. We have to find x1 and x2, and we already derived this iterative formula, so we can directly substitute the value. Like for x of 1, we have to substitute x of 0 over here, and by substitution you can easily get the first iteration value, and similarly by substitution you'll get the second recursive value. Here 0.2 will be kept over here as well as over here. In that way you can easily find the second iteration value as well. Move on to the next question. The next question says start from x not equals to 1. One step of Newton-Raphson method is solving the equation x cube plus 3x minus 7 equals to 0 gives the next value of x1. We have to find the x1 value, means the first iteration value. Okay, so the solution over here I have given for the equation x cube plus 3x minus 7 equals to 0. I have considered it as an f of x. Here is the Newton-Raphson formula which you have to remember in solving each and every question. So this is our f of x, which is equals to 0 over here. So f dash x will be 3x square plus 3 when you differentiate this particular function. So here is our Newton-Raphson formula for the first iteration we want. So here is the substitution, like when you put the value of x naught equals to 1 in these functions, you will get this particular expression over here, and when you solve it you'll get 1 plus 3 by 6, which is equals to 1.5. So the answer of this question is 1.5. You can see all the solutions and you can try it on one more time, so it will be very easy for you to understand. So the next type of question is which I have shown in question number 3. Evaluate root 2 up to the 4 decimal places using Newton-Raphson method. Here they have mentioned like how many places, 4 decimal places. Let the guess value is 1.5. This parameter itself is helping us to find the value. So if somewhere guess value is given, that's for it is given as x naught value only. So here we want to find the root 2. Consider some constant x equals to root 2 like this, and when you square it, it will be x square equals to 2, and when you bring this to this side, so this will be x square minus 2 equals to 0, which is your f of x. Like this you have to proceed. Over here I have given it in the solution as well. Like yeah, first is the consideration, and next one is the f of x formula forming, and by Newton-Raphson method you can easily find the first iteration value, like x1 equals to x naught minus f of x naught divided by f dash of x naught, and when you substitute the value you will get this value as well over here. And for the second iteration you substitute this value over here, you'll get the second iteration, and these are all the calculative steps, so I'm not wasting your time. You can, while trying yourself, you can directly calculate and you can verify the answers. And for the third iteration you can see this is the value. So what you observe over here is for the second iteration and third iteration we are getting the exact same value up to the 4 decimal places. So with the three iteration itself, you have to stop, and you have to say the value which is equals to whatever the answer you are getting for the value of root 2. Here one important point is the answer depends on the guess value. For example, it's very easy for us to reach to the exact value if guess value is given to be a very uh, precise. So if I have given you the guess value of 2.4, then more number of iterations required to reach the value which we got over here, which is 1.41. So basically, if I give you guess value which is more precise or more accurate, and in that case there will be less number of iterations. Okay, so these are the three questions which I want to discuss with you guys related to the Newton-Raphson method. And this method itself is very easy method. I hope you understand it. And I recommend you to try these three questions at your own, and even you can try a few more questions for a better understanding of this particular concept. Yeah, thanks a lot.